Right, the last question on this paper is this integral, and we are asked to use the substitution square root of x is equal to tan theta to integrate this expression here. So as usual with a substitution question, what we want to do is try and use our substitution and rewrite dx in terms of the other variable. Now, so usually we just differentiate it, but I think in this case it would be easier to differentiate if we found x first. So let's say x is equal to tan squared theta. I'll write that as tan theta whole thing squared because I'm going to differentiate it. So differentiating this one gives us dx over d theta is equal to, so to differentiate this we have to use the chain rule here. So bring the power to the front. So it'll be 2 times tan theta, reduce the power by 1, and then times by the derivative of the inside bit. So multiply by the derivative of this, and the derivative of tan theta is sec squared theta. So what we want to do is to try and substitute all of this into this integral here, right? So on the numerator we have 1 minus x, so that will become 1 minus tan squared theta. So I'll write this as 1 minus tan squared theta. On the denominator we have square root of x, so that's going to be tan theta, times by x plus 1 squared. So if x is equal to tan squared theta, I think it would help to just rewrite this here, tan squared theta, x plus 1 is going to be tan squared theta plus 1, but that whole thing is squared again. So this bit is going to be tan squared theta plus 1 whole thing squared times by dx. What we could do is just move that d theta to that side. So this dx term is going to be the same as 2 tan theta sec squared theta times d theta. So this will be 2 tan theta sec squared theta d theta. Okay, so this is the thing that we need to integrate now. So the first thing I would notice here is the fact that 1 plus tan squared theta is the same thing as sec squared theta. So that's one of the standard identities we need to know. So what we have here then is sec squared theta squared. With the sec squared theta term here, we can cancel off one of these brackets here. So we are just going to have, so instead of having sec squared theta squared, we are just going to be left with sec squared theta. Then there's a tan theta there and a tan theta in the denominator, so we can cancel that out. So which means the integral that we are now left with is going to be, so not to forget the 2 here, so we are going to have 2 times 1 minus tan squared theta divided by, so in the denominator one of these powers is cancelled off. So in the denominator we are just going to have tan squared theta plus 1. Now tan squared theta plus 1 is sec squared theta, so I'll write it like that. So sec squared theta d theta. So what we now need to figure out is how to integrate this. Now, like I said before on some of the previous questions, if I have a fraction, the first thing to check is if the numerator is the derivative of the denominator. So clearly differentiating sec squared theta will not give us this numerator here. So then if it's trig, it's a matter of trying to maybe use some identities or try to rearrange it in some way. Now, since there's only one term in the denominator, I think I'm going to split this integral into 2 parts. The 2 at the front here, so we could multiply this n or just keep that outside the integral. I think I'm going to keep that outside the integral and write this as 2 times. I'll write this as 1 over sec squared theta minus tan squared theta divided by sec squared theta. Now 1 over sec squared theta is cos squared theta. So I just want to first figure out, does that simplify to anything nice? Now tan squared theta divided by sec squared theta is the same as writing tan squared theta times 1 over sec squared theta. Now sec squared theta is 1 over cos squared, so 1 over sec squared can just be replaced with cos squared. So this is, so 1 over sec squared, so that denominator can be written as times by cos squared. Now tan squared is the same thing as sine squared over cos squared, because tan theta is sine over cos. So what we actually have here is sine squared over cos squared times cos squared. These two will cancel, so we just get sine squared. So all of this simplifies to sine squared theta. So putting these two together, what we're going to have is 2 times the integral of 1 over sec squared, which we said is cos squared, minus, and we've shown that this bit here simplifies to sine squared theta. Now at this point, hopefully you recognize this as one of the identities. So one of the identities for cos 2 theta is cos squared minus sine squared. So what we actually asked to integrate here is 2 times the integral of cos 2 theta. The integral of cos 2 theta is fairly straightforward, because integrating cos we get sine. So cos of 2 theta is going to be, so it will be 2 times. The integral for this bit is going to be half sine 2 theta plus c. 2 times the half will cancel, so this just gives us sine 2 theta plus c. So now our original integral was not given in terms of theta. Our original integral was given in terms of x, and we use the substitution that root x is equal to tan theta. So we do need to write this back into terms of x, and the way we could do that is, if instead of sine 2 theta, let's write this using the double angle formula for sine 2 theta, which is 2 sine theta cos theta. Now the substitution we were given is that tan theta is equal to root x, and the way I'd like to work out what sine theta and cos theta is just by drawing a right triangle here. And if tan theta is equal to root x, and I said this is equal to, this angle is theta, the opposite side must be equal to square root of x. So tan theta is opposite over adjacent, and this side is 1. And then using Pythagoras, 1 squared plus root x squared is 1 plus x. Square root of that makes this side equals to square root of 1 plus x. Right? So we can use this triangle here to work out what sine theta and cos theta are in terms of x. So this will then become 2 times. So this will be equal to 2 times. Now sine theta is opposite over hypotenuse. So that's going to be root x over root 1 plus x times by cos theta is adjacent over hypotenuse. So that will be 1 over square root of 1 plus x. Simplifying this just a little bit. So if I multiply the two denominators, the square roots will go away. So this becomes 2 square root of x in the numerator over 1 plus x in the denominator, plus the constant c, and that's the final answer.